Are we doing something today? Oh, I was. Oh, no, you're fine. Makes me dance. I feel like I feel like but look on the last page, $100. That's topics.
Sure.
Oh.
Bingo. Wow. Take this link.
Very sure.
Okay. Give me one more minute.
Oh, wait, 1.7.
Okay, let me start with number one. Okay, so number one says consider the curve given by x squared minus xy plus y squared equals 4. Part A is just find 2 points on the curve at x equals 0. So we're not even finding derivative yet. We're just gathering some order pairs. So we'll insert 0 in for x. First two terms wipes out. I'm just left with y squared equals 4. Take the square root of both sides. There's plus or minus that will show up. So y equals plus or minus 2. So the 2 points are 0, 2, and 0, negative 2. Okay. Part B, find dy dx. I don't have to say differentiate implicitly. We should be able to look at this equation and recognize that there's a need for that. Okay, so if we want to find the derivative, there's a need for implicit because we have multiple y's mixed into our equation. We should be expecting how many dy dx's? 2. Yeah. So off the original equation, we should be able to count how many dy dx's we're expecting. So we're going to use power rule and what else? Product rule. Okay, good. And we have to be careful about the negative. The negative can cause some issues if we're not careful. I'm just going to set it up to show what I'm about to do here. Product rule here. Okay, so x squared becomes 2x minus I'm protecting my product rule with the set of parentheses, so I'm remind myself to distribute that negative through later. Okay, f prime g plus f g prime x becomes 1. G stays as y. F stays as x. G prime becomes 1 dy dx. Okay, keep going. Y squared becomes 2y. Dy dx, we're asking for y's derivative. And then don't forget, 4 also getting impacted. 4 becomes 0. Everybody good so far? We're done with the calculus. Now we're just trying to collect the dy dx terms. I'm going to distribute the negative through first. Next up, I will factor out dy dx. And then divide the parentheses over. Part C, use the derivative to find the slope of the lines tangent to the curve at the point found in part A. So we want to find the slopes at 0, 2, and 0, negative 2. So we can just simply insert each order pair into the derivative to find the slopes at those points. Okay, so I get 1/2 for is the slope for the point 0, 2, for the order pair 0, negative 2. Oops, let's see. Sorry. Here, could be 2. Plus. Okay, they both happen to have the same slope. And then we have to write the equation of the tangent lines to the curve of the points above. We can just simply use point slope form. So using this order pair and this slope, I can do point slope form, build one equation. And then here's my second set of information to get my second linear equation. Okay, set up and write equations, but don't solve in order to find vertical and horizontal tangents. The reason why I say don't solve is because it's a little bit more complicated for this one because we have multiple variables in either the numerator or denominator, but if it were not more complicated, I'll be able to ask you to go further. But we know horizontal tangent. Where do we look for horizontal tangent? Numerator of the derivative, okay. And to find the vertical tangent, we set the denominator equal to 0. Yeah, that will be the first steps to gathering. But I did not actually go further for this review because, but if I were to ask you to go further, it would just be one variable for you to solve. Okay, any questions? First page. Next page.
On the test we saw for vertical and horizontal tangents, will like x and y come to equal just one specific number instead of like y equals 2x like it would.
Yeah, yeah. If I ask you to solve, it won't be two variables on the same line.
Okay.
Yeah, you can just solve for x or solve for y, just like how we've been doing on previous examples, right? Okay, page 40. If G is differentiable everywhere, and we see the word differentiable, but we should just be thinking, okay, it's continuous and differentiable. We have a piecewise function. It says find A and B such that our piecewise function can be differentiable. So our strategy here is we're going to set the equations equal to each other because we know that these two functions, they have to meet at the same y value. They have to connect at the same y value when x is equal to -2. And then separately, we can set their derivatives equal to each other because not only do they have to connect with the same y value at -2, they must also connect with the same slope at -2 because it's got to be a smooth transition. It can't be a slope of 2 followed by a slope of 3. They both have to share the same slope in order for us to be able to consider them differentiable. Okay, so I'm going to set the equations equal first. Okay, replace every x with 2. Oh, sorry. Thank you. -72. And so we go as far as we can, but we're going to be stuck no matter where you put your A's and B's. You're not going to be able to solve for A or B because we need a second equation to help us get this down to one variable. So we'll need another set of equation. So let's find G prime. Once we find G prime, we can set those piecewise equal to each other. So we go down and find the derivative. 6x cubed becomes 18x squared minus 16x, and this is for x is less than -2. And then ax plus b, derivative there is just what? Just a. Yeah, ax becomes a, b goes to 0. Okay, use your calculator. Number crunch that, we get a equals 104. And then we can take that and use it to find b on the other side. Any questions with the process? Okay, for number 3, we're going to be referring to this graph here. I have f graph in the solid line and then g of x in dotted line. Part A, h equals f of x times g of x, find h prime of 2. This is what rule do we use to find the derivative here? Product rule, yeah. Product rule. You have two different x's that indicates you have a function. They're not inside each other. They're outside of each other. They're being multiplied. So f prime g plus f g prime. Every x gets replaced with 2. So f prime of 2 and g prime of 2, these are both asking for the slopes of their respective graphs at 2. F of 2 and g of 2 are asking for the y values at those points. Okay, so f prime of 2, we're asking for the steepness of the f graph at 2. And the slope here, down 1/1, so slope is -1. Times g of 2. G of 2, the y value of the g graph is at 2. F of 2 is also share point here, so also at 2. G prime of 2, we're asking for the slope of the g graph at 2, and this is a positive slope. Slope is up 1/1, slope is down. So -2 plus 2 ends up giving us 0. For B, if w of x equals f of g of x, find w prime of 3. Now this one, what rule do we use here? Chain rule, yeah. This is clearly a function within a function. If you had two different x's, then it would be product rule, but So hopefully we can see that distinction between product rule and chain rule. Okay, so outsize derivative times insize derivative. Replace every x with 3. Understand that this is not a one-step process. We got to take our time with this. So deal with the part that feels manageable. So we can handle that g of 3. So let's find that piece first. So g of 3 is this y value. And that looks like 2.5. So we make that substitution, but copy everything else where it is. So now we're only left with 2 more things to find. We need to find f prime of 2.5 and g prime of 3. So f prime of 2.5 is asking for the slope of the f graph at 2.5. So 2.5 is around here, but it's all part of the same line here. So the slope is still -1. And then g prime of 3, we're asking for the slope of the g graph at 3. And what is the steepness here? That's a horizontal line, so steepness is 0. So w prime of 3 is equal to 0. What if there was a problem that was asking for f prime of 3? It'll be undefined. Okay, so I want to make sure we understand that the slanted line, you're going to get a slope value, numeric value. If you get a horizontal line, that's a slope 0. If you get a sharp turn, that's a slope undefined. So yeah, so if one part is undefined, everything is going to be undefined. Okay, part C. Z of x equals 2 times f of x quantity cubed. Hopefully we see that. Let's see. What do we need to apply here? Chain rule. Yeah, there's an outside inside portion, but there's a mix here. The outside and inside are not both in function notation, but we still can just apply the appropriate chain rule for each part. So outside is the bracket and what's bracket and everything outside the bracket. So 2 bracket cube. Inside is the f of x. So we take turns with each derivative. Outside's derivative. This is power rule. So 6 bracket squared. Okay, what goes inside here? Just f of x, right? We're not ready to handle f of x's derivative, not until we get out of this space. Times, now we're ready for the inside's derivative. F of x becomes f prime. Okay, replace every x with 0. F of 0, we look at f graph. f of 0 is at 4. So replace this portion with 4. F prime of 0, asking for the slope of the f graph at 0. And here the slope is still -1. It's all the same slope here, -1. Okay, 16 times 6 is 96 times -1, -96. Part D, k of x equals f of x. So f is the outside, f is the inside. This is clearly another chain rule. So we'll go through the process again. So outside's derivative, so it's f prime of f of x. That takes care of the outside's derivative. The inside's derivative is also f, so f becomes f prime. Everybody okay with chain rule there? All right, every x gets replaced with 4. Let's handle one piece at a time. F of 4, asking for the y value of the f graph at 4. The y value of the f graph at 4 is 2. So all we're left to find is f prime of 4 and f prime of 2. So f prime of 2 is asking for the slope of the f graph at 2. That's a slope of -1. And the slope of the f graph at 4, part of this line segment. So this line segment has a slope of 1. And so -1 times 1 is -1. Part E, p of x equals g of x over f of x. Quotient rule, right? Now these are opposite here, so we just have to be careful that when we say f prime g minus f g prime, that it may be a little bit opposite here. So so it's the top's derivative times the bottom minus the bottom times top's derivative all over the bottom squared. Okay, replace every x with 1. Gather all the information from our graph, g prime of 1. We're asking for the slope of the g graph at 1. It's a positive 1. F of 1, y value of the f graph at 1 is 3. G of 1, y value of the g graph at 1 is 1. F prime of 1, asking for the slope of the f graph at 1, part of this line segment, so slope is -1. All over f of 1 squared, so f of 1 is 3, all over 3 squared. Okay, number 4, find dy dx for our function. We see that there are multiple rules involved. We want to apply chain rule first because the parentheses is over mostly everything. And we want to apply the rule that has a larger reach, larger impact first. So chain rule comes first. And then once we're inside chain rule, then we can handle quotient rule. So outside portion is that 2 parentheses to the 7th. Inside portion is the fraction. Right, so we take care of the outside's derivative first, 2 parentheses to the 7th, that's just power rule, 14 parentheses to the 6th. Okay, now we're done with the outside's derivative. We're ready for the inside. The inside is where we're going to have to apply quotient rule. Okay, f prime, 15x squared. G function. Back to f. G prime. All over denominator squared. All right, we're going to spend time to clean this up here. Distribute the 15x squared through. Now, if I pull the negative 2x in front of this negative, then it's really a minus negative 2x parentheses 5x cubed minus 2. And really, the two negatives becomes positive. So I'm really just distributing a positive 2x through the 5x cubed minus 2. So plus 10x to the 4th minus 4x. All this cleans up to be negative 5x to the 4th plus 45x squared minus 4x. So this is my cleaned up version of this numerator portion of this fraction. Okay, so I'm going to put it all under one fraction here. Numerator goes up top, denominator goes below. So 14 stays up top. 5x cubed minus 2 to the 6th, that goes up top as well. And this whole mess we found to be negative 5x to the 4th plus 45x squared minus 4x, that goes up top as well. Okay, all over my denominator. So I have multiple 3 minus x squareds, right? There's 2 of them here. How many do we have here? Good, 6, right? Pay attention to this number here. If we don't look at this number, you may be tricked into thinking that there's only 1 here, and you may be counting 3, but there's actually 6 plus 2. There's actually 8. Okay, there we go.
So if you multiply and there's exponents, you just add them.
That's right.
Are we gonna have to do anything else with A and B just besides like finding them?
Oh, you mean like at the top of the page?
Yes.
No, yeah, just have to, yeah, it'll be looking like just like that. And find your constants. Right, any questions on this page? Okay, last page. Right, extended, this is extended particle motion problem here. Find velocity and acceleration function. We can just go ahead and find the derivative. Now, if it helps to see things better, you can always rewrite this t to the fourth over 4 as what? 1/4, right? I mean, you can go through quotient rule, but it just feels cleaner to pull it out in front. All right, so power rule twice, once to get to velocity, the second time to get to acceleration. So bring down the 4, 4 times 1/4 is just 1. Minus 3t squared. Minus 4t. Okay, acceleration. Power rule again. 3t squared. Minus 6t. Minus 4. Part B, find when the particle changes direction. It's a multi-step process here. We have to set velocity equal to 0, find what causes velocity to be 0, find those t values, populate our velocity sign line, then check the signs with each subinterval, and then look to see where is there a change in sign. Okay. There has to be a change in sign in order for us to call it a change in direction. Now here, this one's a little bit different because at the very top here, there's no restriction here. It says for all real numbers. That means we want to include negative and positive. So we're not going to start at 0 and just look to the right of 0. Negatives are also going to be part of our number line. I'm going to set set velocity equal to 0. I'm going to go ahead and start my factoring process here. I can factor out a t from each of the terms. Continue factoring, multiplies to be -4, adds it to be -3, -4 and 1. So I have 3 separate t values. So I'm expecting 3 separate solutions. So t equals 0, t equals 4, t equals -1. Okay. All right, here's my velocity sign line. -1, 0, and 4. Okay, are we good with sign line so far? Okay, we're going to have to test these 4 subintervals here. So I'll test -2, I'll test -1/2, I'll test 1, and I'll test 5. Okay. And those test numbers that I haven't read, as soon as we find the signs that are corresponding at the top, we're not going to look at those numbers anymore. Don't include those numbers in any intervals that you're asked to find. So -2, I'm going to plug into my factored form here. So -2, that's negative. -2 into the second, I get negative as well. A negative as well. So 3 negatives makes negative. Okay, I'll plug -1/2 in. So negative, negative, positive. So 2 negatives and a positive will make positive. Plug 1 in, 1 for t, positive, negative, positive. There's only 1 negative, so the whole thing is negative. Plug 5 in, positive, positive, positive. So we can confirm that there's a direction change at -1, 0, and 4, because there's a sign change in each of these each of these times when the object stops. Okay. As a reminder, you may want to just cross off these test numbers because you're not going to use them in any interval that you create. You're only going to use -1, 0, 4, and then potentially negative and positive infinity. Okay, so we don't want to include any of those test numbers for any of the interval statements that we make. Okay, part C, determine interval when the particle is moving left. Moving left is all the negative regions, so negative infinity to -1, and then from 0 to 4. And our because statement is because velocity is less than 0, or velocity is negative. Sorry, I meant to say right for part D. So moving right are all the positive intervals here. So -1 to 0, and then from 4 to infinity. Because velocity is greater than 0. Part E, find the average velocity. Okay, what's our definition for average velocity? Good, change in position or change in time. We do not touch velocity at all when you're finding average velocity, when you're calculating average velocity. So we need to find x of 1 and x of 3. So we can use our calculator since this is a little messy to do. So x of 1 gives us -1.75. X of 3 gives us -23.75. So it's just going to be x of 3 minus x of 1 all over 3 minus 1. So therefore, okay, all that can go in your calculator. We're left with -11 meters per minute. Pay attention to what's told to you at the very top of the page. Change in position over change in time. So numerator is meters, denominator is time. So meters per minute. Part F, find the average acceleration. What's the definition of average acceleration? Change in velocity over change in time. We don't touch acceleration. We use the function above it. Okay. So we need to find the velocity at 1 and 3 seconds. Sorry, minutes. So plug 1 into velocity. Get 1 minus 3 minus 4, which is -6. Plug 3 in for t for velocity. 27 minus 27 is 0. 0 minus 12 is -12. All right, acceleration is meters per minute, so or meters per minute squared. Next up, find particles displacement. Displacement is just defined as final position minus initial position. That's it. We don't do any time component here. So just have to find x of 6 and x of 1. So x of 6 is 37. Plug that in the calculator. X of 1 is negative 1.75. And it's okay to get a negative displacement. If you get a negative displacement, that just means that you end up to the left of where you started. If you get a positive displacement, that just means you end up to the right of where you started. So if you get whatever sign you get, just keep it. Don't drop your negative if it happens to be negative. But this ends up being positive, so 38.75 meters. Distance is similar to displacements, but it can be more than displacement if there's a change in direction between the starting and ending point. So we still need x of 1 and x of 6. But is there another t value that we have to consider? Is there a change in direction between 1 and 6? Okay, there is, right? So if we look at our velocity sign line, we see that there's a change in direction at 4. So we have to also include the location at 4 so when it starts backtracking, we can count the steps from that location. So x of 4 is all the way over at negative 31 on the x-axis. So now he's just imagining walking between these locations here. So you're starting at negative 1.75. You're walking all the way over to negative 31. And then you're walking all the way back to 37. So you're starting here, walking to negative 31, and then you're turning around from negative 31 and walking all the way back to 37. Okay, so we count our steps. How many steps have we taken? If we walk from negative 1.75 to negative 31, we can just subtract those numbers and just take the positive because we're counting steps here. So this ends up being 29.25. And then from negative 31 to 37, okay, you're walking 31 steps to 0, and then from 0 to 37. So that's 31 plus 37, 68 steps. Okay, so then in total, you've taken 29 steps to the left, and then you took 68 steps to the right. Your total distance, you're just going to add those numbers together. Okay, at t equals 2, is speed increasing or decreasing? How do we determine increasing or decreasing speed?
The acceleration of velocity makes sense.
Yeah, we look at the signs. So if velocity and acceleration have the same signs, speed is increasing, right? If they're both positive or if they're both negative, speed is increasing. But if one is positive and the other is negative, then speed is going to be decreasing. So velocity ends up giving us -12. Acceleration at 2 is -4. They're both negative. They have the same signs. Therefore, speed is increasing since velocity and acceleration have same signs at t equals 2. At t equals 5, is the velocity increasing or decreasing? This is not talking about velocity. It's asking about what? Acceleration, right? So if you think about velocity, it's asking about, is the velocity rising or is the velocity falling? So if you think about the rise and fall of velocity, you're talking about the slope of velocity. And slope of velocity is the derivative of velocity, which is just acceleration. So we just look at acceleration. Acceleration is positive at 5 seconds. So since acceleration is positive, velocity is increasing. All right, let me know if you have any individual questions that I can answer.
Is the test gonna be kind of formatted like this?
You said.
You're gonna have like a question at each time.
Yeah, I understand. But no. Oh, yes. Okay.
You said if we do vertical and horizontal tangents, you only have one variable here, so we need to
So if you want to see, example, yeah, I think that.
yeah, like I'll be going back to that.
Instead, one to zero on two, and then steady equals the two. Yeah, I'm gonna find it. I'm gonna very glad.
Can you also tell me which favorite split?
I don't use. I don't sure. Whatever you.
I know, but like when do you take, like once you get the answer to the first one, you take the derivative of that one. So you take the first derivative and then you would do like chain rule twice if necessitated. Okay.
Hands whatever. You need a calculator for this?
Yes.
This is one.
That's right. Yeah, let me show you. I did this before. Let me show them a board. So here, you see x and y are being multiplied, right? So I gotta go to f prime g plus f g prime. I should find whether the derivative of the function that is this term. So f prime, that's x becomes 1. G is asking for just the y becomes the full factor. Plus f, which is x, and then g prime is asking for the derivative, the derivative of y is 1 dy dx, because I'm asking for y.
Yeah, no, it's not, no, it's not. You guys, but then the denominators, they
So you got a 94.
like, this is the.
You have almost
space. And it's
Yeah.
the this sense of the. It's never really not.
I do.
Yeah, I see.
Okay.
Underneath stuff that's like, oh, yeah, so you know,
You mean Farco motion? Yeah, I'll give you this one for that.
because they. Genetic. Think so.
Okay, so, need all your put bags in the front. Make sure your phones are up on the wall. And if you have any smart watches, make sure you put those up as well.